Okay, so here we are looking at the difference between physical and chemical changes. You'll notice right away this is in your textbook, Science Perspectives 9, page 181 to 185 is where this is covered. First, we're going to fill in this chart looking at physical change and chemical change and kind of some examples of both. And then the rest of the note, we're going to look at four main observations that indicate that a chemical change might have happened. Okay, because one of the things that we hope is by the end of grade 9, you're going to be able to identify whether something is a chemical change or a physical change. So let's begin. First, let's talk about physical change and the definition of a physical change. A physical change is something that only alters the form or the state of a substance. Okay, this includes dissolving. And the important thing to remember is that no new substances are made. Okay, so if you take a piece of paper and you crumple it up into a ball, yes, you're changing the form of that piece of paper. It's no longer a sheet, now it's a crumpled little ball, but you're not making anything new. It's still paper, you're just changing the form of it. Similar with water melting from a solid into a liquid. You started with ice and now you've got liquid water, but you're not making anything new. It's still water. So here's some examples. An ice cube will melt in a glass of lemonade. That's a physical change, right? Because the ice cube is still water. Menthol crystals will sublimate or will sublime into a pleasant sweet gas. Nothing new is being created. It's just that you've got a solid going to a gas. A nail is bent when it's hit with a hammer. Again, we're just changing the form of the nail. Nothing new has happened. Grease is mixed with water with the addition of soap. So usually oil and water don't mix. We put soap in there and we get some dissolving happening, and then those two things can mix. And most malleable metal, that's gold. The most malleable metal is gold. It can be hammered into a thin sheet. Okay, so all of these are examples of changes of state and form. And so now let's talk about chemical changes, which has a lot to do with chemical reactions. Okay, and that's what the rest of the unit is about. So this is all about a change that results in the production of a new substance called a product. Okay, when we write chemical equations or chemical reactions in the form of an equation, the stuff that we start with are called the reactants because it's what's reacting, the old or the beginning substances. And the stuff on the other side of the chemical equation, those are called the products. Those are the new substances. Okay. So let's take a look at a few examples. When a log burns, so a log in a campfire, say, new gases like carbon dioxide, carbon monoxide, and water are produced. Okay, so those gases have been created. We also have black soot that's produced. So those are new processes. Baking soda will fizz when vinegar is added to it. We're making a new substance, baking soda fizzing. Milk will go sour, producing a pungent gas and a white solid. An egg is fried. It's another example. Iron will rust and silver will tarnish. The important thing to remember when we're looking at chemical changes is that they can't be undone, right? So when milk has gone sour, you can't unsour that milk, right? When you fry an egg, you can't unfry it and get the raw egg back. All of these examples of physical changes, we can undo them. These chemical changes, a lot harder to undo and sometimes impossible to undo. Okay, so let's take a look at these chemical changes, these chemical reactions, and we're going to talk about, some clues that maybe we've got some chemical changes taking place. First of all, here's an example. Dissolving salt in water. Physical change or a chemical change? If you said physical change, you would be correct. It is a physical change. And explain that reasoning with an example. Okay, so basically when we think about this, salt is dissolved in water, and we know that dissolving is one of those physical changes. And the reason why we know is because all we need to do to reverse this change is to boil off the water. And once it's gone, we get salt. We'll get that salt back. All right. So here's 4 observations that a chemical change may have happened. Now remember, kind of the overall arching thing here is that we don't want to be able to reverse these things. So kind of the 5th thing is it reversible? That's kind of the 5th part of this. Let's take a look now at 4 clues, including the fact that, well, they might not be reversible. Now, these are 4 observations that a chemical change may have occurred. Just because one of them occurred doesn't necessarily mean that a chemical change has happened. Many of them might indicate and might actually strengthen our case. So the first one is a change in color. Okay, not like food coloring being added, but actually the substance itself changes color. So when iron rusts, the color of that iron changes from a silver gray to a reddish brown, right? The actual color of the iron changes. The word equation, the chemical equation in words that defines this reaction is iron, which is a solid, plus oxygen, which is a gas. Okay, these are called the reactants. This turns into rust, which is also called iron oxide. And this is the product of this chemical reaction. Okay? All right, let's take a look at the next clue. Formation of a new precipitate. Okay, so this is the formation of a new precipitate. A precipitate is something where a liquid and a gas will come together to form a solid. Okay, so here a precipitate is some new solid that forms when liquids and or gases are reacted. Okay, so this is often detected. We can sense a precipitate is there when we have changes to the clarity of a mixture. So when something becomes cloudy, we know a precipitate is happening. So a good example of that is in this example down here. We've got carbon dioxide, and we add that to lime water, and the solution becomes white and cloudy. Okay, so new precipitate. Next, energy as heat and or light is either released or absorbed. So if we do a chemical experiment and energy is released, we're going to feel heat, or it's going to feel hot. The test tube might feel hot. If we do a chemical experiment and energy is absorbed, then the test tube will feel very cold. Okay, so a couple of examples of this. First of all, light is absorbed. We know this. We've talked about photosynthesis, right? So we've got carbon dioxide is being taken in through the leaves, and water from the roots. The plant is absorbing light and is giving us glucose and oxygen. Okay, and that takes place in the chloroplasts. So that's one example that we've kind of talked about already. So let's talk about a marshmallow being toasted. We saw this when we went to Wrigley's Corners, okay, or during the Bunsen burner lab. Marshmallows are toasted, right? That's heat being absorbed, and this is turning into something different. When we toast bread, when we cook an egg, when we fry bacon, when we roast chestnuts on an open fire, really, when we cook any food, we're absorbing heat, right? And this is taking those molecules and changing them all around. Okay. Last but not least, light and heat are released. So examples where light and heat are released: when dynamite explodes, okay? When a candle burns. And glow sticks, they make light but no heat. Natural gas in a stove, or as we saw in the Bunsen burner lab, that kind of blue flame, natural gas burns, making light and heat released. Okay. The last one, the last clue that we have down here, we're coming to the end of this lesson, is the formation of a new gas. And if that new gas is formed in a liquid, we might see bubbles or fizzing. Okay. Very often, pop will fizz after removing a cap, or Alka-Seltzer will bubble when we put it in water. That is a chemical reaction happening. If the new gas is released into the air, it can be detected if it has an odor or if it has some color. Now, a colored gas will only be seen if it's very concentrated, and that can sometimes be very dangerous. But in general, you know if a chemical reaction is happening if you smell rotting eggs, because they release a really pungent smell. And composting fruit, when fruit is decaying or composting or breaking down, it has a really, really sweet smell. Here's another example: nitrogen triiodide into nitrogen plus iodine gas, which is a purple gas. In general, though, if we can see a gas, that is way too concentrated and we probably shouldn't be in the area. All right, some of these observations can also be made when a physical change occurs. So, for example, when ice melts, heat is absorbed, but no new substances are formed. So here's the rule: if we're able to make 2 or more of the above observations, then it's very likely that a chemical change has occurred. And this is the important thing to remember. This very, very last line: if we're able to make 2 or more of these 4 observations, then it's very likely that a chemical change has happened. Okay, so there it is, and we're going to get ready to take a look at some of these in labs on Monday.